Hello friends, सबको नमस्ते. So today in this video we will create a people image segmentation model using a DeepLabV3 with ResNet50 as a backbone. Let me show you the dataset. Contain test and train folders. We have images with the mask. Okay. Now you can see that images is in a say these are the images and the format of the images is JPG and the format of the mask is PNG. So during training, we have to make consider that using when we fetch mask path using a image file name, we have to change the extension. Otherwise, it will throw an error. Okay. So this is the helping Jupyter file, which I will explain you when I will explain you this code. And this is a weight which is trained on 50 epochs. So let me open this is in Jupyter. Okay. So this is a Google Colab. So JDown is a library which is useful for the connection of Google Drive with your Google Colab, and just upload your dataset in a Google Drive, and you can get a share link. You can and copy that share link and paste it here, and just delete unnecessary part of it. Just keep the ID of that thing. Okay. Now let me run this part. Now it will first download the data zip file from the Google Drive. You can see that it's downloading. See, this is a zip file. Then you should unzip it. Then this is the you can see that dataset is train, test, and train. We have only one class person here. So these are the libraries which we use for creating the data loaders and data augmentations, plotting the images, CV2, OS. All these are libraries which is useful for creating the model. Okay. And from the model.segmentation, we will upload a DeepLabV3 with ResNet50 model. Okay. So let's get started. It is a necessary line. So these are the directories, train directory. Basically, these two lines give me the file names, a list of all the file names which is present in image directory and the marks directory. Let me run this cell. This is let me check how many files are present. 897. Make sure that the number of images and number of mask images should be same. Otherwise, during training, it will throw error that sometimes it's possible that mask is present but original image is not present. But sometimes possible that image is present but mask is not present. So vice versa will be there. So you have to make sure that for every image there is a mask. Otherwise, during training, it will throw an error. So this is the main part of your code. You can say this is a part where I will explain you that how you segment the images, segment the images and get the segmented image from it. Okay. So this is the directory, image directory and mask directory. Here figure representing the entire figure. Axis here is in 2D format, but after using the label, it will be converted into 1D format. Why we are converting? Just for the easy of iteration towards the subplots. We are plotting 16 images with figure size 20 by 18, 4 by 4, 4 rows and 4 columns. Alpha is transparency. What is how much the transparency is there? Suppose if I will increase the transparency, pink color will be reduced. If I will decrease it, transparency decrease. Okay. The classes which we have is one thing is a background and person. But what is the use of background? Where we are including background just because when we use a pre-trained model, zero index value is always fixed for the background. That's why we have to use zero index value for the background. But there is nothing useful here. Just main part of the main part is just this class colors. Main thing is this class colors which is useful for segmentation. Okay. So this is a whole part which is important thing. Let me explain this whole part in this function first, then I will explain you other thing. Okay. Let me open my help code. See how first thing you have to know that how you can fetch the red channel, green channel, blue channel from the image. Suppose this is your image numpy array. How you will get the red color? Suppose for getting the red channel, just use this image, three dot comma and zero. You will get a red channel. Same for the green and same for the blue. See 25 1 1 2, 25 1 2, 255 3 25, 255 3 225, 128 64 192, 128 64 192. It's act. You can say this is complete. This is a red channel, complete red channel. So in short, you can say that's complete. This row is a red channel. Complete this row is a green channel, and complete this row is a blue channel. This way you flash the red color, green channel, and blue channel from your image. This is a mask because mask is always in a 2D in a grayscale format, so it should be in a 2D format. Here 255 is representing the portion where the segmentation has to be performed, and this is a overlay of 0 with 0 value, and its size will be same as the image size. This is an image. Now this is alpha. I will tell you what is a alpha mean. Alpha means basically a transparency. Class color, basically one is representing the class name because we have only one class, so class index one representing that. And here with the color which we are using is yellow color, 255 See what is use of class mask not equals to zero means all the values where the zero is zero, all the values other than zero will convert to one, and zero remains zero there. So let me show you that in mask we have 255 which represent the portion where the segmentation had to perform. So after using this line, you will get this type of mask. 1111 means 255 value change into 1 because all the values other than 0 convert to 1. Now this is the main part. See what is the use of overlay. Overlay basically used because for getting the blended image we want 3 channel overlay which represent on which portion where the segmentation had to perform. Okay, and mask basically tell us that where there is a portion that particular segmentation has to perform. But overlay give the 3 channel and image have a 3 channel also, so that we can easily calculate everything and we can easily get a blended or segmented image. Now this is the main part where I will explain you how I will get the blended image. Before that, let me show you how the overlay. Before that, let me show you what is. Sorry, not this is not a main part. This is a part where we get the blended image. This is a part where we will change the overlay red channel, green channel, and blue channel of the overlay according to the color which we are using, and according to the mask because marks tell us which is where is the portion where the color has to where the segmentation has to be performed. Suppose that when we iterate over the class color, it will give me two things: class ID and a color. Class then we have to make a class mark. Like here, class marks is a boolean 2D array which represent that on which portions you have to perform the segmentation. Mask is equal to class ID means all the portion where the all the pixels value present in the marks where it is class ID, its value turn to true. Other and all the values other than that will change to false. See the class marks here. The class marks will represent me the boolean 2D array, false, true. You can see that all the places where one is there, it's changed to true. All the values change to false. This way we get a class mask. And one more important thing that when you have to use this line, it is necessary that you have to pass the boolean 2D array. Otherwise, it will sometimes if the process is too long, it will crash your GPU. So if you do not want that, you have to pass a 2D boolean array, so that the processor or so that the during calculation it can consider that which portion it has to perform segmentation. Till suppose what is the use of three basically represent that we have a 3 channel RGB. That's why we have 3 is there. If suppose C is 0, if C will 0, it will have to fetch the red channel, and you already know that we are using 0000, so red channel here also is of 2D array of 0 values. Every value in the red channel of overlay will be 0. Class mask then tell that on which portion which pixel value we have to convert that pixel value with the color C. Here color C, if suppose C is 0, the color C value will be 255. You can see that red channel of the overlay will change only at that portion only to 255 where there is true only. Okay, same for the green and same for the blue. Let me show you. See, same for the blue have only 000 at true portion also, because you can see that when we will went to C, when C will be 2, the color C have 0 value. Okay, color C have zero value, so that's why at blue channel it's a 0 0 there. Now the main part is there. Let me explain you this thing, how we can get the blended image. For that, let me open this in a WorldPad. See this. This is the overlay of R and red, green, and blue channel. 255, 025, all this has happened. After converting that into a complete overlay, you will get this type of overlay 0, 255, 255, 0, 255, 255, 0, 0, 255, 0, 0, 255, 255, 0, 0, 255, 0, 0. This way you have to get the RGB and a complete overlay. Okay. Now this is important part where you will have the calculation how to get the blended image, segmented image. There is an image RGB channels 25500. I already told you how you can get the red and green and blue channel from the image. Just get them, and there is overlay red and green blue channel. There is a mask. See, important thing you have to consider that here you have to pass the Boolean 2D array, not a mask, not a complete mask. You can get, you will have to pass. You have to pass Boolean 2D array. When I will using this mask is equal to 1, actually I am passing a Boolean 2D array in which it tells that all the portion where mask is equal to 1 turn to true, and as where there is other than 1 it's turned to 0. It turns to false. Okay. So this is Boolean 2D array. Now just see this portion. Get me, if suppose C is 0, let me first get the right channel of that. After fetching the right channel, we have to multiply it by 1 by minus alpha, and alpha value is 0 0.5. 1 minus 0 0.5 will actually give me 0 0.5, and when 0 0.5 is actually the half, so I have to multiply with the whole this area with the half, but at only that portion where true is there, according to a Boolean 2D array. So where there is true, true will be at 0 0. At 1 1 true, 0 0 here, true is there, and at 1 true is here, 1 true is here. When you multiply this with 0 0.5, you will see that 255 divided by 2, 127.5, 128 divided by 2, 64, and other values other than true, remain the same. See here, it says false according to a Boolean Boolean 2D array which we were passing. Here is false will be there, so it's nothing will change. And same for the overlay, change only the portion where the true is there, because mass is equal to 1, the portion is 1 here. So this value will get multiplied by half, you will get this value. You will get confused, that let me make it clear to you that why I seeing that. See this, actually here mask is equal to 1, there is this thing. Okay, class mask. If suppose I pass mask is equal to 1, in place of this I will pass class mask, it is same. Okay, so don't get confused that while explaining why I am uh, explaining with the help of the class, with the help of mask. Okay, so don't get confused. Okay, so true is portion, is that portion this, so that's multiplied by 2. When you add this two thing, you will get this thing. 255 plus 0, you will get 255. 0 0 0 remain 127 27. 127.5, 127.5, you will get 255. 191.5, you will get 64 plus 127.5, you will get 191.5. But ultimately we want int values, not this float values. So when you, this is actually the red channel. Okay, and same way you will get the green and blue channel, but we do not want float values. So that so after conversion you will get this type of red and green and blue channel blended image. Then you have to convert that into a complete entire image. So 255, 127, 255, 255, 127, 127, 255, 0, 255, 255, 0, 255, and same way 191, 64, 192. So this way you will get the blended image, and this is a perfect thing to get a blended image or segmented image. Now you will get confused that why I'm converting all things manually. Instead, why do not I can use a function? So let me explain you this thing also. First, I already explained you everything here. Okay. So now we have to reach till here. Image, random select of images. It will first give me the random image file name, then create the image path, and for the mask path, just convert that last four extension with the PNG. I already told you that may consider that using training time. Okay. So you have to read the image and convert that into a RGB, because you have to read image in a BGR format. Now read the image, mask image into a grayscale format. Okay. Here 0 means reading of image into a grayscale. Now just pass the image and you can see the result. Let me run it again. Here I am using a pink color, not a yellow color. Okay. See the result. Okay. It's working good. Now let me explain you that why I am not using a function. See this in most of the images you can see that uh, background does not get changed, does not get affected. But if suppose I use function cb to add bit, which have a same mathematical calculation which we are performing, okay, so see the effect of that. See, I think so. I am not commented. I am commented the function. See, the background get dull. Background get dull. You can see that in every image, background get dull. Okay, see this. The sky is getting dull. This thing happens when we use this function, because it's entirely affect all the pixels. Whether it is a segmented area or not, it's affect all the pixels present in that image. We do not want that. That's why I making all things manually, making a blended image manually. So now see the effects of using a effects of creating a blending image manually. It does not affect my background. The brightness of the background remain the same. See, now see the images. See the difference. Background does not get affected. Only the segmented area get affected. Now we are using DeepLabV3-ResNet50 model, which we have uploading with our models. And here Torch.Cura, I already explained you all things, that what is the use of device here, which tell us that models and means CPU model and images and all things has to be on the same device, otherwise it will throw an error. Okay, that's why we have to make one variable device, which can help to make model to device. Make means model has to be flow from CPU to GPU. If suppose model is in GPU, if we device we are using GPU, so it's flow from CPU to GPU. Now DeepLabV3 ResNet50 with default background pre-trained models which we are using. Let me upload this. Let me print this so that I can explain you next two lines. Right, what is we are auxiliary classifier and what is the classifier for here. See this. See, last layer of this classifier is 256.21. What is the meaning of 21? Means this model is pre-trained on 21 classes, and this auxiliary classifier we do not need it during training. There is useful methods, useful things, useful meaning you can say to use the auxiliary classifier. But right now I do not want to use this auxiliary classifier, so that's why during training I make sure that model.auxiliary classifier is equal to none. We do not need that, but we have to change this last layer of the conversion layer with according to the number of classes which we have. See, that's how we are doing. You can see that it's a fourth layer in classifier. In classifier, it's a fourth layer we have to change. Say model, go to the model, go to the classifier, get the fourth layer, and convert that into according to classes which we have 256, and we have two classes, background and person, and kernel size will be one. This way we have changed, and we have already told you that we do not want auxiliary classifier, so we have said none. So this is everything. You can see this is important. Let me run it now. The model is ready. Now this is a data set which is useful for the DataLoader library, which is responsible for the for uploading the data set for the training. So person data set, this is a class name which we are using. This is initializations of the initialization of the, you can say, directories, which is responsible for fetching the images and the masks and returning the mask and the images. Okay, so image directory, mask directory, transform, basically data augmentation if it's any data augmentation is required. Okay, this is an image file name, this is a transform. We have only two class, background and person. Length gave me the number of images which we have for training. Then IDEX, you can know that IDEX basically useful that to fetch the image file name from the directory. Okay, just create the path, just pass the image directory and image file name with the IDX, you will get that. And same for the marks file the IDX. Okay, so you will get confused at why we are not replacing the extension, because here we are getting mask file name from the directory itself, so we do not have to change it. We have to not change from JPG to PNG. We can directly read the images, convert that image into RGB, read the image in grayscale format. Then what is the use of this? Mask and p bare means where the values is greater than 0, convert that value to 1, and other values remain 0 itself. That's why. And why we are doing it? Just for this, just to say that all the value, just to say that I already told you that when I am explaining that process, I use 255. Okay, 255 for the portion where the segmentation is there. So this might be chances that the areas where the segmented area is there, they use different value. Just and for us, just for that we have only one class. So to represent that particular class with 1, we change all the values greater than 0 to 1. Okay, that's why we're using this line. Then in any data augmentation, augmented is used, silver transfer, just image and image, and augmented here contain two things, image and mask both. Then this way you will fetch that and pass the image and mask, and marks derived will be long. Let me run it. This is a transformation or data augmentation which we are applying, resize, normalization, and converting the image into a tensor format. These are the directories, validation directories and train directories. Just create the train dataset object, validation data object, pass the parameters according to the constructor which we are using in the class, image directory, train directory, and transform. Using a DataLoader library, just pass the object, best size will be here, shuffle true, drop last. Drop last basically drop last fetch. Okay, even if it's contained even if it contain 8 images, last fetch will be get dropped. Okay, and validation data fetch size shuffle will be false, because in during validation or evaluation we don't need any shuffling, because just we are testing the images, but not testing the images, testing the model. But during training we require shuffling. The loss which we are using, cross entropy loss. The optimizer which we are using, Adam, model parameter 0.01. Let me run it now. Now let me see how many images, how many batches is there. Train loader, we have 112 batch, and for bad loader we have 37 batch. How many number of images for dataset? Train dataset 897 and 292 for the validation dataset. Now go for the training. Not training. Here's a plottation. Why we are plotting here? Because just to change, just to see that particular mask is mapping a correct image or not. Okay, just for the sake that during training nothing wrong will happen. Alpha transparency, this is a class name, background, this is a class colors. This is the first, it will create the iterator of the wheel order, and just next will give me the images and mask. Images here contain 4 images and mask contain mask of 4 images. Now 4 to we are plotting 2 column before, it means ultimately we are plotting 8 image of size 20 by 15. Image permute numpy supply. What is use of this? Let me explain one thing happening. First, image I, if suppose I value is 0, must first image will get fetched. Now, use of permute 120. What is the meaning of permute? When because during data augmentation we are using two tensor which convert the image dimension from height, width, and channel to C channel height and width. Okay, when we use tensor. So, but during plotation, I am sure function required dimension is height, width, and channel. So. When we use permute, it will change the dimension from chw to hwc, and we want that particular image should flow from gpu to cpu. That's why we are using cpu. And what is the use of numpy? When the use of numpy is that this time when we fetching the image, it is in a tensor format, so we have to convert that image into a numpy format. So why we are converting it? Because during plotation or during calculations we require it. Yeah, we do not want this. We are doing whole this thing with function. See one more. The reason that I am converting numpy, because in this part, in this function, all calculation is performing, and for the calculation we required numpy format of image and mask. That's why I'm converting this in a numpy. Okay, so don't get confused. That's why we are using numpy, and just plot the image. See the plotation segmentation is good. Now you will see that images is highly contrast because we normalize the pixels value. That's why it's highly contrast images. So don't be so don't so worry. And why we are normalizing the pixels value, you can see that to increase the speed of training and better for the computation. In computation speed increases. Now this is Best loss model path will be sparse model dotted. These are the list which contain the epoch losses. Okay, train loss and validation loss, because we have to plot the graph also. So I will train it for just 5 epoch because I already have a weight file which is 350 epoch. If suppose my model will not perform well after 5 epochs, I will upload my model which is 350 epoch and show you the result of that. The learning rate which we are using, learning rate schedule which we are using is cosine angle. Optimizer is responsible for the updation of the weight. That's why we have to pass the optimizer. And T max epochs means TMS epoch basically means here is that learning rate value will decrease from the initial value to the value, say to the value of 0.0000 मतलब 6 50 and 6 50 and then 1, till that minimum value of that learning rate value will be this. You can see that in one line. initial value Initial value is initial value is that what we have defined our, and the last learning rate value will be this, which is I already highlighted it. And during this at each epoch value, its value get decreases from initial value to little bit at each epoch. The value will get decreased, but the last value will always be this one. And after that epoch, after this epoch's value, you will get that again the initial learning rate value. This way the learning rate schedule acts. Now we are iterating over the epochs. Now model or train means model is in a training mode, and with updation of the weights is there. Okay. Now epoch train loss we have to but why we are using, we want that at each iteration of the batch the loss will get accumulated so that we can plot the graph. Okay, just to make iterate over train loader, images and maps should be on the same device. Optimize of zero grid. What is the use of this? Because if we do not use this, the gradient value will not get zero. And at each, why we are using at each batch iteration? Because suppose we do not use it, the previous gradient value will get accumulated to the current gradient value and affect the updation of the weights, and accuracy will get affect also. That's why we do use optimizes zero grade add, which make the gradient value zero. Okay, and updation will perform correctly. Now just pass the images and out to fetch the prediction. Use this out column because output of the model will use it in a dictionary format. So that's why just pass the output and mask both in a criteria. Will get the loss. Loss dot backward basically calculate the weights values according to the loss, and optimizer dot step basically update the weights according to a calculation. Now epoch train loss basically you will load the losses of each batch. Now just get the average loss and pass this and append that into a train loss list just for the plottation of the graph and print the masses. Now model is in evaluation mode. We are not evaluating the model. We have to check that how the model is performing on unseen data set. Same way, if I parallel with torch no grade. What is the meaning of that? Means no gradient, no gradient is used, no operation is performed. Now a model is in an evaluation mode. The same way, iterate over it, make the prediction, pass the criteria, calculate the loss, and print the masses. Now, if suppose average validation loss means this time we are using the validation, so that's why it is important that you will save that model only, which have a less validation loss. So average validation loss will, if suppose average validation loss is less than best loss, because initial best loss value will be infinite, we will change the best loss value and save that model. Scheduler loss tab always in a epoch for loop, not in a validation for loop, and not in a train for loop. Okay, it should be always in a epoch for loop. That we learn it. Training gets started. This is a plotation. Plot figure size will print by 6. Train loss. Give it a train loss list label, and marker 0 is called because it highlights the point. Because use of this marker is to highlight the points. Color will be 0, blue and red. Labels will be epochs. Y label will be loss. Training a validation loss. Okay, this way we make a plotation. Now this is a testing time. Let me run it. If suppose the training get over, it will show the graph. This is a model path which is model which is saved by during training. Make device variable which is useful, you already know. Then upload the model using a ResNet50 and class to background and person. Just way you will get the model. Then you will load the dataset and just use the device. Model means flow the model from CPU to GPU, and now model is in evaluation mode. Then there is a test directory. Image means give me the list of all the images present at. There's a already explained you this 2 line. Use of alpha, use of class colors, transformation, all the pre-processing which is happened on images before training has to be there on testing also. That's why we are using it. All the pre-processing. Now random choice of images, get the image path. So sometimes images present in a testing is in a grayscale format, so it's make sure easy to convert that into RGB. If it image in RGB, it does not affect that. If suppose the image in grayscale, it change that into RGB. Now use of this, apply the transform to the images. Then unsqueeze this. What is use of unsqueeze? Because during training we pass the images into a batch format, so same format we have to pass the image into a testing. So to add one dimension we are using unsqueeze, and that to make the model and image into a same device we're using two device with torch no grade. What is the use of it? Means no gradient is there, no aberration of weights has to perform, and this model input tensor out 0. Here out till out will get the prediction, but to get the image prediction, first image prediction, you will use 0 here. We are just passing the one image, so use 0 here only. Okay. Now torch.argument max will give you the predicted marks from the output, And what is the use of CPU here? Because the marks which we are getting is in a GPU. So to GPU, so we want that now I want to flow the predicted mask from the GPU to CPU. So that's why I'm using CPU. And use of NumPy here is that the predicted mask is in a tensor format. You already know that we have applied the transform. So predicted mask is in a tensor format. So I want to convert into a NumPy, because when I'm using uh, this function, I want all things into a NumPy format. That's why I've converted into a NumPy. And image is also we convert into a NumPy. And you have to first get the image path and original part. And suppose the predicted mass is might be chances that predicted mass is not in a size of image. So to make the predicted mass in the size of the image, we have to use CBD resize that pass the predicted mass, original width and height according to this. And interpolation means fill the pixels with the nearest pixel. Means you can say that pixel which is empty, or you can say pixel which is not there. We can fill that area with the nearest pixel. Okay, now just pass the in image np prediction mask and class. You can see get the blended image. And now we can see that our training cat over with 5 epoch. Now you can see the graph. You can see the graph. You can see it, and you can also see that what use of marker. Marker basically highlight the points, and you can see the model is pretty good working well with even if the I will train on a 5 epochs. You can see the segmentation here, segmentation which is performed by the model on unseen images. So this is over now. You can see that now you can download this model and use anywhere you want. Okay, whether in your web application, Telegram bot, or you can say mobile application, anywhere you can use that. Okay, please like, share, and subscribe my video for more videos like this, where I had explained you each and everything, each line carefully with deeper details. Mainly this thing how we can make a segmented image. Please like, share, and subscribe my video.